Hi everyone, and welcome to Datacom Lab number 2 on IP and ICMP. We're going to investigate IP fragmentation as well as ICMP, echo requests and echo replies in this lab by using traceroute. Okay, so the traceroute uses echo request and echo reply in order to map the hops, all the hops between a client and a server, or like a web server, for example, that serves a site. Okay, so in this lab we're going to have Wireshark. We're going to use Wireshark. If you're in Windows, you can use Ping Plotter. And I'm going to show you Open Visual Ping or traceroute, basically. Open Visual Traceroute as just an interesting tool that you can visualize the location of all the routers that are hosting, or servers that are, well, routers along the path to a server that hosts a website. Okay, so let's take a look. What do you need for this lab? First thing you need is go on Econestoga and download the two lab documents. This is a PowerPoint presentation, so you can also download the presentation, which will have this video. You probably already did that. So manual.doc, this is all the manual with all the steps we're going to follow in the lab. It has questions. The location of the questions in the manual will kind of tell you what to do. But you're actually going to answer the questions in this answers.doc file, because we don't need the whole manual when you submit your responses. Okay. So, and the next slide is this video walkthrough. So let's close this up. I'm going to show you the two documents. When you download them, you've got this document is where you're going to actually put your submission, answer your questions. All the answers go in this file. Okay, and then we have in here we have the lab document. Okay, a Wireshark Lab IP and ICMP. Okay, and we're gonna use the traceroute. Okay, so traceroute, if you remember, it uses ICMP, echo requests and replies, with different TTLs. So if you want to find out, for example, I'll give you an example. You want to find out the first hop router. Well, you'll send an echo request, which is basically a ping, with a TTL of 1, okay, off to your first server or router. And the job of the router is to decrement the TTL and pass it on to the next router. But when the TTL reaches 0, the router has to drop the packet and send an ICMP message back to the original sender. So you can see if you have you have different TTLs. So if the next time the client sends a message, or using traceroute, the next ping, you have a different higher TTL. You'll get to the next router before it drops it. So you'll keep getting messages from routers along the way at every hop, and that'll show you how to what the path to the server looks like. Okay, so to do this visually, I'm going to show you. I'm going to first show you Open Visual Traceroute. Okay, this is kind of a cool, something nice to show you. Anyway, you can go in and you can download over here Open Visual Traceroute. That's at SourceForge, so you can go right here and you can download it. Now I've already downloaded and installed. Just use the defaults. There's nothing special to doing this. So Open Visual. Did I spell that right so far? Nope. Open Visual. Okay, so I've got it here. So this runs traceroute. It'll run it in Windows here, and it will. What it does is it overlays on Google Maps, Google World. Okay, the location of the different routers along the path to a server. So it's kind of an interesting thing. It's using traceroute in a visual, graphical way. Okay, so we can go here. I'll just show you a couple things. So this destination is just the server you want to reach, right? So www. Let's go to google.com and we set our start. Now, for this lab, the echo requests what we want is we want a tool that is capable of changing the packet sizes of the echo request, because we're going to be examining IP packet fragmentation. Okay, so this program doesn't have that capability. Okay, so we can't use it for the lab, but I just wanted to show you. Okay, these are all the hops between my computer, okay, and Mountain View, which is where Google servers are. Okay, if you want to go across, it's a really nice tool, because if you want to go across the ocean, let's say Europa, I actually tested this out just to make sure. You can see that it's going to show all the hops to get to the other side of the world. Okay, that these packets are being sent, and how they get to the server. Now the server could be located, there could be multiple servers, so every time you do this it could change. And not only that, the paths that the packets take could be very different. Okay, so and also sometimes this program will show you the satellite links. Okay, sometimes some of the packets could go undersea using the undersea cables. Some of them could be using satellite links, etc. Okay, so just something interesting to show you. This is your standard trace route. It's going to show you all of the different servers, well, all the different routers to get to the server. Okay, so this is great, just as a visualization tool for using traceroute. Now, there's a couple ways that we can do this lab. We can do this lab from Windows, and if you do it from Windows, Windows has its version of traceroute. However, its version of traceroute does not have the ability to change the packet size. So if you're on Windows, there is a utility called Ping Plotter, and it's at www.pingplotter.com that you can go to and you can download. Okay, now when you download this, so we can go in and go to it. It's a 14-day trial. Now, I did this a couple years ago. I've used all my computers already to trial this, so I can't actually do that for this video. But you have this 14-day trial that you can use. It's fairly simple, and what you're going to do, it's going to ask you, we installed Wireshark. When you installed Wireshark, you had npcap was likely what you installed. But if you installed winpcap, okay, then when you install this program, it'll say, oh, you already have winpcap installed, so do you want to still install it or not? You don't have to install it in that case. Okay, but if it's not installed, then install winpcap, because that's what Ping Plotter uses. Wireshark, when I installed it, I used npcap. Okay, so anyway, if you get this, you can get it up and running. The issue that I can't actually show you is that when you're in Ping Plotter, okay, when you get into Ping Plotter, if it shows for the free version that you've installed, if you've never installed it, you're eligible for the trial. You can go to help, and in help you can set, actually I can go in and show you at least that part. So Ping Plotter, I can go in here and you can change the version. You may need to change the version to use the see, I'm on free, right? You can go to change editions and you can try the professional. Okay, so if it's showing you free here, go to the help and then go to change editions, then go to Ping Plotter Pro. That's what we need in order to be able to change. Okay, so when you go to edit, you go to options. Okay, within Ping Plotter, I don't have this shown to be able to change the packet size, but when you have the Pro version, okay, it'll look like this. So you're going to go to options, you're going to go to default settings, go to engine, and this lab, we're going to have three settings for packet size. 56, 2000 bytes, okay, so 56 bytes, 2000 bytes, and 3500 bytes. Okay, so what we're going to do is we're going to generate trace routes to, and I show you, where is it here? If you use this or you use, I'm going to show you from Ubuntu in this video, but you go to gaia.cs.umass.edu, and you've already set what you're going to do is change the packet size. So you're going to have 50. You're going to start Wireshark. Okay, you're going to change the packet size. You're going to start at 56. Then you're going to run the trace route. Okay, you run it. You press play. Okay, or press go here. You're going to run it for 56. Then you're going to go back. You're going to change it to to 2000. You're gonna run the traceroute while you're gathering in Wireshark, and then you're gonna go back and change it to 3500. Keep gathering in Wireshark. Once all that is done, you're gonna stop. Okay, you're gonna stop your trace, and then we're gonna take a look at the different packets that were sent for each of these. Okay, you can either do it one at a time, or you can do it. You can do 56 capture, then take a look at the questions, then do 2000 capture, take a look at the questions, and then 3500, or you can just do it all at once and just know the order that you did those packets. Okay. So that's what we're going to do. Now, I can't actually use Ping Plotter right now because my trial period has expired. So I'm going to generate my packets in Ubuntu. Okay, and the benefit of this is that it's free, it's always available, and traceroute is always there. So in order to do this, if you want to, you can do it this way, or you can in this lab, you're going to see the examples here of what the outputs look like, okay, what you're looking for. And it's going to be the same regardless of what we do. But before I go to do that, I need to be able to generate those packets. So I have to open up, first of all, I have to go in and open up my VMware. Okay, now I go here. I'm using Ubuntu 20 for this example. Edit your virtual machine settings. So what I'm going to do is I'm going to use, in my network adapter, I'm making it bridged. What does this mean? This means that my virtual machine, okay, Ubuntu, is going to be treated like it's a computer on my network, because the virtual machine is going to be assigned an IP address by my router, which must be configured using DHCP. Okay, so my virtual machine, the IP address of my virtual machine is going to be different than that of my computer. Okay, so I'm going to need also Wireshark installed on my virtual machine. I'm just going to do it because I think it's a little bit simpler to see everything. Okay, and actually I can see the packets sent on my own interface. So I want Wireshark installed at the IP address of the VM. Okay, so make sure if you're following along with this that it's bridged. Okay, and then we can start up the virtual machine. Now, if we go in here, we have, where am I here? To do this, what I need, I went through this install already just to make sure everything looks correct. Go in here, let's open it up. Once it gets set up. So we need to install NetTools so that we can see our IP address. We need to if we want to use ifconfig to get our IP address. Okay, and we also need, let me go down here. We also need traceroute. Now, how you install this is important. Which traceroute? There's different versions, and some of them will not give us the functionality that we want. Okay, so let's let that install, and then we're going to install Wireshark on Ubuntu. Okay, so let's wait for Ubuntu to load up. Open it up a little bit here. Hopefully, it will give me. Okay, so we got Ubuntu, and we need to install these different components here. Okay, let me close that so I can see. Okay. All right, so what do we need to do? Okay, so a couple things. Let's open up our terminal. Did it not click the terminal? Okay, open it up again. All right, so here, first thing I need to do is install NetTools and traceroute. Okay, but first let's go in here. Let's go. See, I want to be able to say ifconfig. Oh, where am I typing that? So say if. So something just froze on my machine. Okay, let me see if I can unfreeze it, and we'll get back to you. Okay, my machine just unfroze. Okay, so anyway, what we need to do, I want to be able to say ifconfig. So this is, I want to know the IP address of my Ubuntu. Okay, so ifconfig not found, but it knows the repo that it belongs to. So it's nettools. Okay. Now, just to show you, I want to say that. So I'm going to go command in the Windows. So this is Windows right here. Okay. So I want to know what's the IP address of my Windows machine, and that's ipconfig, right? And I know that I'm connected to the internet on my Ethernet cable, with my Ethernet cable, and my IPv4, I'm connected by Ethernet 2, IPv4 address is the .100. Now I'm going to show you that it's not the same on when it's bridged in the VM. Okay, so if I go in, I'm going to say sudo apt install, I need nettools. Okay. Now I actually give you this. I show you here a nettools and then traceroute. Okay, it's asking for my. Okay. So it's going to install nettools so that I can say ifconfig. All right. Now I'm connected if you're wireless, you might be iwconfig. Anyway, ifconfig. In here, you see I'm .34. Okay, so this the IP address of my Ubuntu machine is .34. Okay, next thing is, okay, that's clear. Now we need traceroute. Now the question is, there's a couple different versions of traceroute. Now, right now I know nothing is installed. This is a vanilla installation of Ubuntu. Okay, traceroute's not found, but look. There are two repos, two versions of traceroute. Okay? If you install this one, you will not be able to change your packet size. That's a problem. Okay? If you install this one, this is the one that we want. Okay? This is the one that will work. Okay? So, go sudo apt install traceroute. Enter. Okay? And it's going to ask you, do you want to install it or no, it's just going ahead and installing. Okay, now when I say traceroute version, you're going to see that it's the same. Okay, if you install, you can tell the difference. You can tell which one is installed by looking at the man pages, right? Okay, so let's go back and just go traceroute version, and you can see that it's modern traceroute for Linux version 2.1.0. Okay, so that's great. This is the one we want. If I go man traceroute, I can go in here and I can see, okay, traceroute, okay, and then what it's asking for. So it's traceroute, and then where is it here? Traceroute. Where did it go? Yeah, here it is. Okay, traceroute, host, and then packet length. Okay, if we had a different traceroute, it would not give us this option. If we use the other one, it would not give us the option for changing packet length. Okay, so make sure that this is the one you have installed. Okay, so now I'm going to quit here. Okay, so this is what I want. This is the one I need to use. Now, the other thing about traceroute, this traceroute command, okay, is that by default it uses UDP packets instead of ICMP echo request and reply. Okay, that's just the way this traceroute works. So if we want to use ICMP messages, we need to use this -i command. Okay. Now I haven't yet installed Wireshark, but anyway, we're gonna do that as well. Actually, what I should do is put in here. I should put, actually, let me go like that. Okay. So go in here, and then I'm going to say sudo, and then Wireshark. Now, why did I say sudo Wireshark? I haven't installed it yet, but I'll tell you. When you call Wireshark, in order to be able to see the interfaces, okay, that are on the computer, basically the Ethernet interfaces, you need to be root. Okay, so when you open Wireshark, you have to open Wireshark as root. Okay, now I haven't yet installed it, so let's do that. So sudo apt install Wireshark. Okay, so we're going to install Wireshark. Now, if you don't, I'll give you an example. What happens if you don't log into Wireshark. So if I just type Wireshark, or if I put it on the make a desktop or favorites, it will not show. Look, watch. I'm going to open up Wireshark. Okay, look. I'll show you what happens if I see. I can't see my Ethernet interface. Okay, it's not. I don't have the permissions to view it, so I can't actually see anything. So I need to be root when I log in. Okay, so if I go sudo Wireshark, okay, now watch what happens. Now I have, see this ENS33. This is my Ethernet connection. Okay, loop back. I don't really care about any. It's not something like I care about this guy right here. So I can double click it. Capture is starting, but I don't need capture yet. Okay, so what am I going to do? The main goal is to capture all the packets. Okay, when I do a trace route, okay, to this location. Now remember, okay, the way it works, we're going to call trace route. So let me actually make, because I need more space here, right? Okay, this one is running the Wireshark as sudo as root. So make a new window. Okay, so now this one is going to be for the traceroute commands. So basically, I need this traceroute to Gaia, right? .cs.umass.edu with packet size, different sized packets. Okay, so here are the different options. I'm going to be 56, 2000, and 3500 here. Okay, for these sizes. Okay, so what do I need to do? I need some more room to kind of show you all this. So I'm going to make this a little bit smaller, zoom this guy out a little bit so we can see this, and we're going to capture packets with different sizes here. Okay, and then we answer the questions based on those packets. Okay, so we go here. All right, so what do we need to do? We need to have Wireshark running. Okay, and then here, actually, the first thing I can do is just go trace route. Okay, dash. Okay, so here I'm using ICMP echo requests in order to do this. Okay, then Gaia.cs. That's the destination. UMass.edu, and then we're gonna have different packet sizes. So 56 is the first one, and then I'm gonna run another trial of this with 2000, and then 3500, and then stop the capture. Okay, so if I go here, start the capture, I'm not gonna save the previous capture. Great. Now go 56. Okay, do the same thing, change it, go 2000, enter, and then now 3500, not 35,000, 3500, enter. Once that's done, stop the capture. Okay, so now we're ready. We're done. We've done our trace routes. We're using ICMP echo requests in order to do this. That's what the -I is for. We have the destination, and then we have different packet lengths. Okay, so if you remember, why do we do that? I'll just kind of take you back to this. We don't need this open anymore. We're good. We did all our trace routes. So why do we do this? Why do we change the packet size? Well, in Ethernet, or even in Wi-Fi, the maximum transfer unit, the MTU, the maximum packet size for Ethernet is 1500 bytes, right? Now we said IP has this capability to fragment packets, okay? And that's what we're studying here, that the packets are going to be fragmented if they're bigger than 1500 bytes. And so we're going to be studying this, okay? So we're going to see with the different, so with 56 it's not going to be fragmented. With 2000 you're going to have two fragments, right? And then with 3500 you should have 3 fragments. Okay? So that's what we're going to observe by doing this. That's the whole point of what we're doing. Again, if you use ping plotter to do it, no problem. If you use what we did, great. Okay, so now what we're going to do is we're going to go through the questions, right? And we have these traces. So we're doing it by here. It's organized by packet number. So we'll be able to tell, you know, which groups of packets, you know, belong to which trace route command. All right. So what we're going to do We've already done all the capture, so that's great. We have it here. And we have the different, right, with 56, 2000, and 3500. And then we stop the tracing. If you're not able to, you can download. There is a zip file here with traces, but it's not going to be from your computer. It's going to be different. All right, so next step, we're going to go through the questions here. Okay, so in your traces, you should be able to see the series of ICMP echo requests. All right, let's go and move that over here a little bit. Okay, so we do, if you want, okay, so it says ICMP. So what we can do is, if we don't really care about DNS requests and other types of requests that are shown here, we can filter out for ICMP. Now, it has to be lowercase, otherwise it doesn't work. So ICMP, these are all of the ICMP messages that were sent. Okay, and you should see, because we use the -I, we have echo requests, and then you're going to see replies. We got to see TTL exceeded, etc., etc. Okay, so these are responses. So look, these are responses. If you see, look, 192.168.1.1, that's my router, right? Saying, listen, TTL exceeded to .34. Remember, that's, in my case, that's my VM. So because it's bridged, it's able to respond directly. Okay, so we see this. So that's what this is saying. It says, okay, you should be able to see those. In the questions below, we'll assume you're using a Windows machine. It doesn't matter, really, in this case. Corresponding questions for the case of Unix, they should be the same. No, don't worry about that. Whenever possible, when answering the question below, hand in a printout of the packet with the trace that you used, etc., because that'll kind of make things easy to understand. Okay, in case there's some issue. All right, so that's the thing. So it says here, select the first ICMP echo request message sent by your computer and expand the Internet Protocol part of the packet in the window below. So, okay, this is the very first one. This was sent to 192.168.134, and the destination is, this is that U Massachusetts thing, right? If we look in the picture here, Gaia is here. We look here. 128.119.245.12. Okay, so is that right? 128.119.245.12. It's a known destination address of a particular server. So that's good. So that's great. So we have that, and then we're going to open. We're going to open up not the Ethernet. We're going to open up the IP portion. Okay. So we did that part. Okay. Do not set the filter to ICMP, or you will not see the fragments. I see. Okay, so what I can do here, in this point, I should be able to. Oh, I won't see the fragments. Yes. Let's take out the filter for now. We're going to keep this one selected, and then take this one out just for now. Okay, so I have this. This is the one that I selected. Okay. All right. Fine. Okay. Let's just make sure everything is exactly as. This is the request. This is the very, very first request. Okay. That's fine. Okay, so there we are. We're here. There's no fragments. Okay, we're not going to have fragments in the very first one. Okay, so just to keep it nice and clear. These were the DNS queries that we sent. Basically, what is Gaia, right? Gaia, what's the actual IP address of Gaia? That's what that is. That's what the DNS query is. Okay, so let's go here. Okay, first question. What's the IP address of your computer? Well, okay, that's pretty simple. 192.168.134, that's mine. You're going to have to check what yours is. Within the IP packet header, what's the value of the upper layer protocol field? Okay, so we'll go here. We expanded this. What's the upper layer protocol field? Boom, right there. Okay, so that's what we're looking for. All right, let's just make sure everything is nice and clear. All right, what's the next question? How many bytes? Oh, where are we here? How many bytes are in the IP header? How many bytes are in the payload of the IP datagram? How did you determine the number of payload bytes? Okay, so now what do we need to do? We need to go in. Okay, and for question 3 is how many bytes are in the header? Well, the header, I mean, it's IP, right? Number of bytes in the header, we know, okay, is what? There's 5 words, right, in the header, and you can actually look at the header here. You can see how many words there are in a header, right? 1, 2, 3, 4, 5. 4 words per, sorry, 4 bytes per word, right? Times 5. It's 20 in the header, right? Okay, so we got 20 bytes in the header, which is standard, and in the first packet that we sent here, we sent 56 bytes, right? We send the 56 bytes. So how many bytes are in the payload, right? It's our header minus, right? So total length is 56, right? And we know that in our header we have the header length is 20 bytes, 5 words. That's what 5 is. Okay, so 56 minus 20 will be 36. Okay. Next, has the here we are. Has the IP datagram been fragmented? Okay, has it been fragmented? How do you know if it's been fragmented? Well, look. Here we have no fragment offset. So what's the fragment offset? This is the offset in bytes from the start of any fragmented packet, right? And look here, flags, right? Are there more fragments? No, there's no more fragments. So this is not like there's no fragments to follow from this one, right? This is the first one. No fragments are following. Okay. What else? Okay. Oh, and look at the data offset. Where's the data offset? Fragment offset. Where's let me see here. I have it up here. Identification is, no, that's not what I'm looking for. Anyway, okay. The fragment offset is 0. Okay. Let's go to the next question. Okay, here it's asking us, sort the trace packets according to IP source. Okay, so sort them according to IP source address by clicking on the source column header. So that's up here. Okay, so if we click them here as increasing. Okay, so we're going to increase according to the IP. So it's sorted by IP, the IP address. Okay, that's fine. What does it want? A small downward pointing arrow. Actually, we want to sort it down, so we can sort it the other way. There we go. Downward pointing arrow should appear next to the word source. If the arrow points up, click on the source column again. Select the first ICMP echo request message sent by your computer. What's my computer? Well, this is another computer. That's not my computer. Here we are. This is standard query. But this is what I'm looking for, right over here. 192.168.1.3.4 sent to there. This is the very first one that was sent. See, you can sort by time if you like. Okay, you have source and time. So this is 1.59 seconds. If you really want to see, make sure how many. This was 1.5 seconds after start. So this is really the first one. This is the 56 byte one. All right, let's go here. So select and expand the Internet Protocol portion of the details. Okay, so let's go. ICMP echo request sent by your computer. Expand the Internet portion. We did that. Internet. The details of selected window and window the second select box window. So that is right. It's this guy right here. This guy right here. This is the details right here. Okay. Okay, I can make this a little bigger. Okay. So we're looking at this. Make sure we're the same. Details of selected packet, second box in the window. Okay. Right here. Oh, we already did that. When we clicked it, it's already open. Okay, no problem. So this one that I'm showing here shows for 3500, right? This is for the 3500 packet, but you're going to see them for all the different options. And we're going to see which one belongs to which. Okay, in the listing of captured packets window, okay, that's this guy, you should see all of the subsequent ICMP messages, perhaps with additional interspersed packets sent by other protocols but we already organized things here. Use the down arrow to move through the messages sent by your computer. Okay, so we go through here, and basically we're going to answer these questions. So which fields in the IP datagram always change from one datagram to the next within this series of messages? Which ones stay constant? Which ones must stay constant? And why? And then describe the pattern that you see. Okay, so we look here, and we're going to look in here to see what happens. What's changing when we go from one message to the next? So let's go here. What's changing? Okay, so look, the identification is changing. You can actually see it. Okay, the identification is different because different packet. What else is changing? The header checksum is changing, right? What else is changing? The validation, time to live is changing, right? You can see at the bottom there the time to live is changing. Anything else? Anyway, these are the things. So what stays the same? Let's go through it and see what's not changing here when I look at it. Okay, the version is the same. What else? Total length here is the same for this particular packet, but we're going to see that it's going to change. The total length can change, right? What else? The header length is always the same, right? Version is the same. Let's see. The source and destination IP address is the same. What else we have here? It's always ICMP as the upper layer protocol here. You can go through and you can see these are really simple questions. Okay, the next question is describe the pattern you see in the identification field. Okay, so the identification field here, just look, when you go through these, what's happening? It's incrementing, right? You see it's going up by 1. Every single time it's going up by 1. Okay, what else? Let's go to the next. All right. Next, with the packet still sorted by source address, find the series of ICMP TTL exceeded replies sent to your computer by the nearest first hop router. This should be black. Okay, you may have to scroll down to the lower messages to find it. Okay, so you go in here. What we're looking for is these black ones here. Okay, so this is sorted. So here, look. Let's go to. I gotta find the one that is my. So TTL exceeded. These are all TTL exceeded. TTL exceeded. Okay, but you see, look, this guy right here is my router. That's the very first one. Okay, so what I'm looking for is that guy. All right, because next with the packet, find the series of ICMP TTL exceeded replies sent to your computer by the nearest first hop router. Okay, should be highlighted in black. You may have to scroll down to the lower messages if the identification is 0. Okay, so let's see identification. Okay, so sometimes this comes with, sometimes it's the relative and sometimes it's the absolute value of the identification. Okay, I think in the Linux version of Wireshark it's a little different, but we'll see. All right, so what's the value of the identification field in the TTL? And the TTL. Okay, so let's just make sure everything is correct here. So look, this is an ICMP message. It's the TTL. When the TTL goes to 0, that's when the time to live is exceeded, right? We know that. So what's the time to live? This one is 64. So something is not exactly correct here. Let's go and see what it is we are looking for, because we should. Let's see. What does it give us here? What is it giving us here? What is the value of the identification field and the TTL field? Okay, so we're gonna have. Let's see. We can go. It's asking for the very first one. So let's take a look at this very first one. What's this one here? These are not the packets. These have TTL of 254, right? This is not. Let's see here. What we're looking for, let me see here. these ones are also, let's make sure that I got the right ones here. Okay, we're looking through TTL of 254. Okay, these are all the fragmented ones. TTL of 244. Time to live of 64. They should be, go in here and just make sure. Okay. Let's go and check. Okay. So what I have actually, so that is what we're looking for, is the TTL values here of those packets, those responses. So these are the responses. Oh, okay. So look at here. These are the responses. So let's go back and just make sure. These are responses from intermediate routers. They're sending back an ICMP message that says that the time to live has been exceeded, right? So their messages don't have a TTL of 0. Okay? So that's why they're 245. Okay? Because this is just a response message. It's an ICMP message from the router back to us. Okay? So that doesn't mean that they're going to have a TTL of 0. Okay, so that's the main point. The identification is just whatever it is here. Okay, so here I'm looking at identification is 0 here. Okay, for this one, let me go to these ones and just check. The identification for this one, they're all zeros. Okay, sent back. They all have identification of 0. Okay, so that's that one. Okay, so these are zeros. Some of them may not be zeros. They may have different, like you see this one, right? This is from my router to my computer. The identification is not exactly 0 here. Okay, but anyway, the TTL, the main point here, TTL is not 0. Okay, so that's the, because it's the reply. It's not the actual the message that was sent by my traceroute client out to the to the intermediate routers, basically. Okay, do these values remain unchanged for all of the ICMP TTL exceeded replies sent to your computer by the nearest first hop router? Okay, so if you look, the identification field previously, okay, if you look at the identification field, what we need to do is we need to go, okay, we're on question 8. Okay, so in one case, some cases, the identification is non-zero. In other cases, identification is 0. Okay, so on my local router, when I look at the messages from my router to me, right, to my computer, the identification is not always 0. Okay. This has to do with fragmentation. Okay, so actually we're if it's gonna have to do with the fragmentation. We're gonna look at it in a second. Okay. Okay. So we're looking at question 9. Okay, we did the value of the identification field and the TTL field. They are whatever value they're going to be. They're going to be some value, and the TTL field is going to be non-zero, right? Because it's whatever the TTL was set to minus the number of hops to get back from that router to our computer. So, do these values remain unchanged, or do they change? Okay, so the identification field is always going to, it's going to change for all ICMP TTL exceeded replies. This is a unique value. Okay, this is the ID field. If 2 or more of these identification fields are the same, that indicates, okay, if you have, so when they're the same, when the IDs are the same, then they belong to the same. That means that you have fragmentation. Okay, you'll have fragmentation here. This flag will be set. You'll have fragmentation, and but the IDs will be the same, so that you know which fragments belong to the same packet. Okay, so that's the idea here. It's what's happening here. Okay, so that's what's happening there. Let's go to the next one. Sort the packet listing according to time by clicking on the time domain. So this is going to tell us the order in which the packets were sent. So this here now we'll be able to tell which one belongs to the 56 byte size packets, which one is the 2000, which is the 3500. Okay, so now we know, because now it'll be in the order that we actually did this. So this first group is the trace route that we did. The first trace route we did. Then we have another trace route happening somewhere a little bit later, etc., etc. We're gonna go through these packets again. So here we'll go through them again. We'll go through them again and do everything nicely. Okay, so these first ones are the first ones that we set. You're gonna see here the packet size. Where did it go? Here, total length is 56. When you go down, we're gonna go down like over here. What's the total length? It's still 56. Let's go down to these ones. Are they still 56? Okay. Let's go down one more. These are going back. These are the 1500 ones. Okay, you see, 1500. These are the packets with 1500 in the thing, and these are the fragments. Okay, we're gonna look at them in a second. Okay, let's go through the questions one at a time. Find the first ICMP echo request message that was sent by your computer after you changed the packet size to 2000. Okay, the total length field will say 2000. All right, now let's go. It's in order. So let's find the first one that is 2000, and it's the ICMP request 56. So let's go down until the total length here hits 2000. Until we see the first one that's in the 2000. These are not yet 2000, and they're different protocols. So we're gonna Okay, we're here. This is going to be it, but there's something. Let's go here. So let's go here. Okay. All right. So this is the very first one, I believe. Let's just make sure. 20 bytes, total length 63. Okay, it's right over here. Okay. So how do we know that this is the one that was here? We can look. There's a couple of places we can look. Let me see here. We can go down to, let me go here, data. Okay, this one is fragmented. Okay, this is the first part. Let me see if I can find for you. These are reassembled. How do I know? How do I know what this is? The total length here is 1500. The next one should be 1540. Is it 1540? Or sorry, 520. Yes. Okay. Okay. So the first one is fragmented because the more fragments bit is set, and the one that comes after it is 1480 from the previous one, because you have to subtract the 20 bytes are for the header, right? So this one, the data starts at 1480 because the biggest, this one, okay, this packet, 1500 bytes, okay? But you have to take 20 bytes, right, from the header. So now the data that was transferred in this packet was 1480, okay? And then this one basically has to take the rest. Okay, so this one is going to be 520. Okay, so because of the header. So here we have, in total you're going to have the 2000 bytes that are set. Okay, that are sent over. Okay, so we can see here, this is the first one. This is our first packet. okay, and it's fragmented. Okay, this is our first fragmented packet, and it has to be reassembled. Okay, so you have two. This is the first fragment. This is the second fragment of that packet. Okay, so this had to be fragmented en route because 1500 bytes, and then the rest were sent 520 or the leftover. The offset is 1480 because that's where the data starts, right? The second packet starts at 1480, and then you need to go 520 in order to get to the end of the packet. Okay. Why is all this? Because the maximum packet size is 1500. So the first packet was 1500, but 20 you have to subtract, so 1480, right, for the data, and then from 1480 over to 2000, right? That's 520 bytes. So the next packet has 520 bytes plus its header, right? So it's going to be 540 bytes total, right? Okay, so let's take a look at what the question is here. So packet size, has the message been fragmented? Yeah. Why? How do you know? Well, you've got the first one is fragmented, right? This one's more fragments. Okay, that's been set, and then when you look, the fragment offset. This one is the first one because it has a fragment offset of 0. This one is the second one because the fragment offset, the data offset, is at 1480. It starts at 1480 from the previous packet. Okay. Sure. Okay. Below. Yeah. So so print out the first fragment of the fragmented IP datagram. All right. So you look at this one, right, and then you can go in here and you can copy, right? You can copy all visible items or all visible tree items, right? Which is what we have here, and then you can paste that into your Word document. Okay, print it out. What information in the header indicates the data has been fragmented? We already talked about that, right? More fragments is set, right? The second one doesn't have any. That bit is not set because there are no more fragments to follow. Okay. What information in the IP header indicates whether this is the first fragment versus a latter fragment? Well, you can see that the first fragment, right, has a fragment offset of 0, right? And also the IP, there's more fragments coming. Second fragment doesn't have it, right? And also it gives you the fragment. There's no more fragments, and it has an offset of 1480. Right? So here, look, the second one, you see this? It says, here it tells you actually, in here, if you pull down this, you can see, okay, this doesn't, but the second fragment tells you, look, you can see 2 IPv4 fragments, 1980 bytes, okay? So the first one is 1480 of data, right? And then the second one is 500. Right? So from 0 to 1479, 1480 bytes. And the second one is 1480 to 1979, 1980, 500 bytes. Okay, and there's 2 fragments. Reassembled IPv4 length is 1980 because originally the packet was 2000 bytes including the header. Okay, so that's the point. If you look, let's look down here for some more things. This just tells you about the ICMP header. Okay, this is the ping request. All right, let's go back and see what else we have. Print out what information that's been fragmented. Okay, what information in the IP header indicates whether this is the first fragment? We already did this. How long is this IP datagram? So the IP datagram we saw is 2000 bytes, but 1980 of data, right? So the total is 2000 because of the header, right? And what else can we say? We are right. Okay, so the very first, actually, they're asking us about the very first datagram. That's 1500 bytes. Okay, where are we here? 1500 bytes is the very first one. That's what they're asking here. How long is the IP datagram? Because it's fragmented. This is the first, right? The first fragment. Okay, yeah, okay, that's fine. Print out the second fragment. Well, that's this guy. Again, do the same thing. Just go here, right click, copy, you know, the all visible selected tree items, etc. And then what information indicates this is not the first data fragment? Well, the offset, right? And that offset, and then are there more fragments to this one? No, because it's 2000, right? It's the second in 2000, so it's not going to be. What fields in the IP header between the first and second, what fields change? Well, the more fragments and the, right, the more fragments change, right, between the first two, and the fragment offset, right? Okay, so that's good. What else? We're going to go here. How many fragment? Okay, so sorry, this is for the 3500. So we got to go down to the next one. So find the first ICMP echo request message that was sent by your computer after you change the packet size to 3500. So it's by time here. So if we go, we can look. Go down to here. We're going to keep going down. Let's see here, 1500. Then there's another one after that. This one, see more fragments set. So this is still part of the first set because it would be fragmented three. There would be 3 fragments basically, right? If you look here, see fragment count 2. Okay, so that's we expect 3 because 3500 would be 1500, 1500, and then the last 500. So let's keep going until we see more than. See, still 2 IPv4 fragments. So let's keep going until we get more than, see, still two, and I'm looking here, okay? All right, so keep going down. I'm looking 2, let me go a little faster. You could not have to do this if you just, do the captures one at a time, but I'm just doing them all at once. I'm interested in these ones, so here we are. Not the first one, not the second one, but the very last one. Okay, so we found it. This is it right here. You see, 3 IP. This is it's always the last fragment that gives you how to put them all together. So we started up here. This is our very first one. And you can see right here, fragmented IP protocol. Offset, this is 0, 1480. Okay, and this is the very last. I see. It's this guy right here. Okay. So 1, 2, 3 fragments. Okay, and there's no more fragments on the last one. And we have the fragment count. Okay. So let me see here. Maybe I missed something. Yeah. Okay. So this is the very first one. This is from me over, this is the ones that I sent, right? From me over to there. So this is fragmented because it's IP, and then this is an ICMP message because, why? Because this got fragmented by IP, and then finally gets reassembled and into a single packet that's an ICMP packet. Okay? So that's why this is what it said. This is an ICMP map. And this basically tells you how to reassemble everything. Okay, so this one, you have 0 to 1479, 1480 to 2959, 1480 bytes. Remember, 1500 plus, or 1480 plus 20 bytes is the header. 20 byte header is 1500, which is the max. And then you have the last byte here, the last fragment here. Okay, so we're here. Now let's go back to the questions. How many fragments? 1, 2, 3. If you go to the very last fragment where it's all reassembled into an ICMP message, you can see 3 fragments right here. Okay, and then what fields change in the IP header among the fragments? Okay, this is the same as before, right? You got basically fragment offset is different, right? Because the first fragment is 0, the next one is 1480, the next one starts at 2960. Right? 1480 plus 1480 is 2960. Okay, so that's that. What else is there? So you can print them out if you like. The total length changes between the two. Let me just go what fields? Yeah, that's the same. What fields change among the fragments? Basically, your total length is going to change here, right? The total length is going to change, right? 1500, then 1500 for the second one, 1540 for the next one. This more fragments is set for the first two, right? But not for the last one, right? More fragments bit because there's no more. And that's really about it. Let's go here. See what else we can see. What fields change? That's basically it for the questions. You're gonna have to go and put in your details. You know what you saw here, and that's basically it. That's the lab in a nutshell. You're seeing fragmentation, right? You're seeing how the messages are fragmented, okay, and then what they look like when they're put back together. Okay, so that's basically it. Okay, if there's any questions, please let me know. But that's the lab in a nutshell, and that's how you do it from the two. Whether you do it from Windows or whether you do it from Linux, you could try both if you like, and see what it looks like, and enjoy a little bit the lab. Okay, so again, that's it for this lab. And if you have any questions, send me an email, or talk to me in class. All right, have a great day. Bye-bye.